So in the lab we measured something called cutoff frequency, but we didn't talk about how to calculate that. That is dependent on the capacitors in the circuit. What you've learned, let's just refresh our memory here, what you've learned in your courses, both this one and AC, is that a capacitor is an open circuit to DC and it's a short to AC, but we haven't really talked about when does it make this transition. Let's review some of the terminology with respect to frequency. So resistance is a term that you would use both in AC and DC, and that's because it's the impedance of a resistor, which is constant and pretty much the same regardless of frequency. However, reactance, there's two types of reactance. There's inductive reactance and capacitive reactance. This changes with frequency. In the case of a capacitor, Xc is 1 over 2 pi Fc, which means that it is inversely proportional to frequency. As the frequency increases to infinity, Xc becomes 1 over infinity, or 0. So a capacitor is a short to high frequencies. An inductor, on the other hand, as the frequency increases in an inductor, as F approaches infinity, XL also approaches infinity, so an inductor is an open circuit to high frequencies. So the question is, when does it make this transition? If I draw a circuit, and I'll just put a little circuit down here, got some AC coming in here, my pens are running out, gotta put the caps on. So here I've got a circuit, here's a resistor, here's a capacitor. So let's apply an AC voltage to the input of this. And let's start. And what we're going to do is we're going to sweep the frequency from 0 hertz to infinite hertz, or a low frequency up to a high frequency. And let's consider what happens. So down at the high frequency, we know that at a high frequency the capacitor is 0 ohms. So at a high frequency this capacitor is going to short out. So over here at infinite hertz, or someplace close to it, basically if this is the out of this circuit, there's the out. If this is the out, at some point we're going to get nothing out of it. So over here we got nothing. Likewise down at the 0 hertz, if we apply 0 hertz to this circuit, this capacitor is open. Here's my V in here, if I'm applying this voltage in, if this guy is open circuit, then V out will be equal to V in. They'll be the same value. So at the low frequencies, we will get an output something like this, and at high frequencies, we'll get an output something like that, way down there. And at some point in between, let's see, what's going to happen? Is the voltage going to go drop off like a stone, where this is 999 hertz and this is like 1001 hertz? I think that you've seen both in this course and your other course, AC, that this is not the way the transition is made. There's no like magic value that instantly takes the output from 100% full to 0. The actual output falls in a transition as 1 over 2 pi Fc. As F slowly increases, Xc starts to decrease. So it's a slow transition between a high output and no output. So what is this thing called cutoff frequency, and how is it determined? Well, since there's no magic value that says this is the point where the circuit no longer works, like over here clearly it doesn't work and over here it does, but at some point on this line we have to pick a point that we say this is the point where it makes a transition between working and not working. And that point is when the capacitor voltage has fallen so that it's equal to the resistance that it is connected to. So in this particular circuit down here at low frequencies, you can see that the capacitor has all the voltage. But when it shorts out at high frequencies, the resistor has all the voltage. The cutoff frequency is the point where the voltage across the resistor and the voltage across the capacitor is the same. Now usually this is where I say, oh, let's imagine that this is 1 volt RMS here. That means the cutoff voltage is when the voltage across the capacitor is half a volt RMS. Right, Mr. Nelson? And the answer to that is wrong. What you're forgetting is that when the voltages are equal, we have an R, which is on angle 0, and we have an XC, which is angle minus 90, and that there's a phase shift. So when the voltages across the resistor and the capacitor are the same, you're actually 45 degrees off your axis, which means that the voltages don't peak at the same time, they peak at different times. So the cutoff frequency occurs when the voltage has dropped down to 0.7071 of the peak voltage, or 1 over root 2. So basically in this circuit here, when the voltage has fallen down to 70%, here's the maximum value out here. When it falls down to 70% of its full value, we say that that is the cutoff frequency. And we would say the stuff on this side of the line, we would say that this is not working. And over here on this side of the line, we would say over here the circuit works. And over here, it don't works. And the cutoff is when the capacitor voltage drops to 70%.